I'm glad he doesn't sit right there. All right, page 138 in your textbooks. We did the review number 7 through, I say we as if I did it. Y'all did. Page 138, review number 7 through 10, and the practice, numbers 1, 3, 6, 7, 11. We're going to start with the 7 through 10, and then we'll look at the 1, 3, 6, 7, 11. Good. Yes, 1? Okay, 1 period, parenthesis. Okay, I was like, yeah, gotcha. I see where we are now. Thank you. Good. Good. Yeah. 1 through 6, 11, 7.
I accidentally said 11. Oh. 7, and then I realized.
It's okay. The important thing is they're all done. They're just really out of order, which is slightly awkward. Good, Genesis. Put Bob in his place. He may be Bob the second. I am Bob the first. All right, so I can't. Anyway, for
I'm
those
distracted.
Gavin and Brecken, there is a large star-shaped shiny red balloon in honor of Michael's birthday. It is wrapped around his wrist and has eyes, a nose, a mouth. It says Bob the second. Anyway, so it's a mild distraction, but I am thankful he's not sitting right in front of the camera, because every now and then you would see nothing but shiny red balloon.
My birthday already passed.
All right. Yes, and I'm thankful that Genesis did. Actually, I wouldn't have let you wear the balloon in this class, or I would have moved you with Kendall or something. We're on page 138, and number 7 through 10. Number 7, what did you have to do to solve this kind of quadratic equation, kind of radical equation? What did you do, Genesis?
I moved to parentheses things.
Good. Factored it.
Yeah. And I split it into x and x.
Well, that would be an x squared, not an x to the half. How do I split a half? For instance, if there's half of a cookie cake, and you want to cut that in half, how much would that be? Half of a half. What is half of a half? Or maybe a white cheesy pizza, and you want to take half of a half. I was not offered any, by the way. I'm not insulted or hurt, nor am I bitter.
I can't think right now.
Well, maybe Michael could answer.
It's a fourth.
A fourth. And really the reason it was hard, Genesis, is we didn't take the time to make this 2/4. If you did, I think you see the 1/4, 1/4. That's the reason I suggest getting the common denominator. It's not absolutely necessary. If you can see, okay, split a half into a fourth and a fourth, but it helps to see that. Then from there, we also need to split up our negative and our 27.
Sounds a bit different. And then you'll get up. I had 7 and 3.
That's 21, yeah, not 27. All right, brain malfunction. Helper, Michael.
9 and 3.
9 and 3, where we want the 9 to be the positive, the 3 to be the negative. And then from there, what will we do with each of these factors, Genesis?
7 and 0.
Good. And so we'll end up with x to the 1/4 is equal to,
-9.
and x to the 1/4 is equal to
+3.
+3. And again, the 1/4 power is just the 4th root. So what do we do to both sides of each equation?
Take the 4th root.
What already is a 4th root? So if this were the 4th root of x equals -9, because that is what it is. To get rid of a 4th root, I would need to, Michael?
Raise it to the 4th power.
Raise it to the 4th power. Remember, the power will cancel away the root. Well, here we don't have to write it as a radical to raise to the 4th power, or the way I said it before, the reciprocal power. The reciprocal of the 1/4 is the 4, and we'll do that to both sides of each of these. And that'll end up giving me, of course, here just an x is equal to, and then she had 7 and 3, so someone 9 to the 4th power?
6,561.
6561? All right, and then here when we raise to the 4th power, that one we should all have memorized. 81, it's a lot simpler. But we need to check, right? Anytime you're raising to a power, you run the risk of creating extraneous roots. It's a radical equation. And so we need to take this, let's start with 81. Square root of 81, class. 9, because that's what the 1/2 power means, it's just square root, so 9. The fourth root of 81, of course, we know is 3 times the 6, 18 minus 27 equals 0. And then calculators at the ready potentially. The square root of 6,561, 81. The fourth root, this one we should know already, the fourth root of 6,561, 9 times 6, 54. Minus the 27 equals 0. No, that one's extraneous. What was my clue that one probably, or at least good chance it was going to, I won't even say probably, it'll say good chance it's extraneous. Right?
It was a negative 9.
It was a negative that became a positive when I raised it to the even power. That's oftentimes where those extraneous roots will come from. How did I get 81 with 6,561 is extraneous? Okay, several of you questions on this. All right, let's take a look at the next one then. Very similar problem. Where we have the x to the 1/2 or 2/4 plus 2x to the 1/4 minus the 80 equals 0. Kendall?
You change the 1/2 to 2/4.
Okay.
And then you pay backwards for you.
Okay.
So you get x and 1/4, x and 1/4.
Go to the 1/4.
And then signs are different, so plus and negative, and then 10 and 8.
There we go. The 10 and 8 will give us the positive 2 from our outer inner if we're careful there. So with x to the 1/4 is equal to
Negative 10.
and
8.
positive 8. Of course, we need to
Raise it to the 4th.
one of these. I'm already wondering if it's going to be extraneous, class.
Negative 10.
The negative 10. But let's raise them all to the 4th power anyway. You never know. What is negative 10 to the 4th power, anyone?
10,000.
10,000. Of course, we know there's going to be 4 zeros because it's to the 4th power. Then 8 to the 4th isn't one we've memorized.
4096.
4,096. And so the question is, which of these or both of them checks out? What's the square root of 10,000, class?
100.
100. The fourth root of 10,000, of course, is just times 2.
20.
Minus 80 is equal to 0. No, we already wondered if that would be extraneous. Square root of 4,096?
64.
64. Fourth root of 4,096? 8 times 2? 16 minus 80 is equal to 0. Yep, and that one checks out. So again, just the one answer there. And how many have that for this one? Number 8. All right, questions on 8? Any questions on either of these? Yes, sir. Is that a question? No, you're just playing with the string on the balloon.
Yeah.
All right. I won't begrudge you. It's your birthday. You have one more year of childhood in which you cannot be held legally responsible for your own actions. And then, boom. I know. No more juvie for you. It says, he hasn't actually been, just for the record. Right, we don't have ex-cons in here. And Brandon, we make an exception for him. All right, we have x negative 9 raised to the 5/4 power is equal to 32. Reconcile. Man, they're just letting anybody in these days. What do we need to do on this problem, Maddie?
Raise both sides to the 4th.
Good, and I like the way she said it. Raise both sides to the 4th power. Perfectly articulated. You could be a math teacher. What are we left with on the left-hand side? You may not want to be, but you could. All right, what are we left with on the left-hand side?
X negative 9.
Y'all don't start praying like he'll over and die just so she can be your math teacher, though. And then over here, we need to take the 5th root of the 32. Stop praying for that. Well, it's not sacrilegious. Don't stop praying. Stop praying for that. Is it positive negative 2, class? No, because it's an odd root. So just positive 2 to the 4th power? 16. And we end up getting x is equal to? 25. How many had 25 on number 9? Questions on that? Like hand, we got it? All right. Number 10, we had an x plus 6 to the 4/3 power equal to, there it is, 256. That's not the right problem. That's the one we just did. And Audrey.
You raise both sides to 3/4 power.
There we go. Not quite as smoothly articulated, but we got there, all right? That's the important thing. And so what are we left with here?
X plus 6 equals 64.
Good. The fourth root of 256 we'd memorized is 4, but since it's an even root, rather, it's not just 4, but positive negative 4. Technically also positive negative 4i, but we're not worried about the imaginary stuff right now. So the 4 and the negative 4, and when we cube 4 and we cube negative 4, we actually get a couple of numbers here.
-64.
There we go. So when we subtract away the 6, we end up with x is equal to,
-70 and 58.
and there we go. How many have those two answers there? By the way, do note in the directions it does say find the real solutions for each equation. So that's why we didn't need to have the positive, negative, 4i minus 6 or anything like that. Only real solutions there. Questions on 7, 8, 9, or 10? All right, let's look up at the top of the page now. And we began looking yesterday at absolute value equations that were also quadratic. So quadratic absolute value equations or absolute value quadratic equations, however you want to look at it. But the first couple of problems on the top portion, numbers 1 and number 3, those were just really straightforward, just ordinary, easy equations. So let's see, Brandon, let's give you one of these. And number 1, what did you get for your answers?
X equals 2 and -13.
What's 5 plus 7?
12. I meant, yeah, that's what I meant, yeah.
All right, so -12 and +2 were your answers. All right, and then number 3, f is equal to.
Oh, 20 and -8.
See, there we go. I knew we'd get it if we had a chance at redemption, and you did. 20 and -8 are answers. Anyone need to see either of those worked? Any confusion on that? We need to make sure we've got that before we look at the next ones. All right. Well, let's go then to number 6. And this one had the quadratic element, where the first two did not. But the process doesn't change. Abby, we still need to start by making two equations like he did on the last couple problems.
Y squared plus 3y equals -2y equals 6. And y squared positive 3y equals 2y plus 6.
There we go. And of course, each of these is a quadratic, so we need to say each of them equal class to 0, and then try to factor, or, what about that's up here? But anyway, so we're going to bring the 2y over, send the -6 over, and the +6 over. What do my two equations become, Kendall?
Y squared positive 5y positive 6 equals 0. And y squared positive 3, no, positive 1. And then -6.
There we go. Of course, we need to do the backwards FOIL here. And Michael?
You get y. You get
We're asking ourselves.
positive.
Not a balloon.
2 and 3.
All right. And of course, over here, Genesis will factor this into y and y.
It sounds a bit different.
Positive, negative, negative.
They're into
3 and 2. And so we end up with 4 possible answers for y. What are they, Maddie?
2, -2,
-2, -2, and
-3.
-3. Okay, I thought I heard 3. There is another -3. I'm not going to waste my time writing because I'll just cross it out because it's a duplicate anyway. There is a little clue here, and we saw these yesterday. They don't always give us negatives over here, but they did in this problem again. And I know if I plug a positive in here, class, times a negative is going to be, and then -6 or -6 is still going to be negative. An absolute value cannot equal a negative. So any positive values down here, we can ignore. We know they're going to be extraneous anyway. So we'll rule out the 2. Let's check on the next 2 numbers we had. If I plug in a -2 class, -2 times -2 is positive 4. 4, -6, -2. Again, absolute value can't equal a negative, so there's no point even checking it over here. I know that's extraneous. Let's try the -3. -3 times -2 class. 6 minus 6, or -6. Well, I suppose absolute value could come out to a 0. Square the -3. -3 times 3. -9. 9, -9. 0. And absolute value 0 is, of course. So the only answer that should have checked for us, I believe, there is the -3. And that is correct. How many got that on number 6? Just the -3 checking. Questions? All right, let's take a look at number 7. We have the a squared positive 2a equal to 4a positive 8. By the way, if we have a big negative right here, that would turn this negative. And if this negative is more than an 8, it would make the whole thing negative, right? So that's, again, little shortcuts you can use to rule out values without having to do the whole check, because That's really the most annoying part of the process, in my opinion, right? How many would agree? You don't really mind solving it, it's having to check it that's such a pain. So there's some ways you can shortcut the check. This is like a -3, -4, -5, -6, anything like that, this is going to become bigger than negative, or bigger, it's more negative than an 8, right? But as far as solving it, Abby,
Make 2 equations.
you do the last one. Where do we leave off? We were wrapping around the room here. Maddie, hey, let's make 2 equations.
Okay, a squared plus 2 equals 4 plus 8. And then a squared plus 2a equals -8.
All right, and of course we want to set them equal to 0, send everything over here. Do you have to draw the arrows? Certainly not. Audrey?
A squared -2a -8. A squared +6a +8.
And of course we'll backwards FOIL all of this, Brandon.
A plus 2, and then 4, and then A plus 4, A plus 2.
And of course all of those are equal to 0. So what are my possible A answers, Abby?
-2a plus -4.
And then that's the duplicate -2. All right. Negatives plugged in here. -2 times 4, class?
-6. 8.
-8 plus 8.
0.
Okay, so this could be a go, all right? And so square the -2, class. 4. -2 times 2, -4 plus the +4.
0.
Absolute value of 0 is
0.
0. So that one checks out. The -4, on the other hand, would give you a -16. Plus 8 is -8. I already know it can't be negative. Let's rule out the -4. Let's try the +4 here. 4 squared.
16.
And 2 times 4. 8 and 16. 24. Absolute value of 24. 24. And of course here, 4 times 4.
16.
Plus 8. There's the 24 as well. So 2 answers this time. The -2 and the 4. How many got both of those? On number, whatever that was. 7? All right, questions? All right, then our last one for the homework before we go do a little bit of other practice here was n squared +6n, absolute value of all that, equals -6n -35. Another one where they gave us a bunch of negatives so I can rule out any positive answers, which is kind of nice. And here, let's make our 2 equations. Genesis.
N squared plus 6 equals -6n minus 35. And n squared plus 6 equals 6n plus 35.
And it was a 6n, I believe. Yes, plus 6n. I don't know if I heard the n or not. I always hear it when Maddie says it, but anyway. So Kendall, let's set these equal to 0.
N squared +11 +35. And then n squared equals 35.
Good. Here we're actually not going to set it to 0 because they cancel. We just get the n squared equals 35. So here we need to backwards FOIL, Michael.
You get n plus 12 and n plus 30. Oh wait, no, n plus 5 and n plus 7.
There we go, and it does check out or enter. So we get 2 possible answers here, the -5 and the -7. And then over here, it's not going to be pretty. What do we end up with?
I just did positive negative square root of 35.
There we go. Let me make sure this is all the way on the screen because we went toward the edge of the chalkboard. Yeah, we're making it still. All right, so I said right off the bat, any number class that is positive won't work. Well, there's only one choice like that. That's the positive square root of 35. So we can rule that value out. Plug in a -5 here, class, times -6, positive 30. That's not enough positive, right? Because you can still come out -5 there. So we can rule that out. -7 times -6. 42 minus the 35 is 7. So this value could work. Let's try it in here. Square it.
49.
And then multiply by 6.
-42.
49 -42. And of course the absolute value is 7, 7. So that one checks out. Calculators at the ready. Well, let's take the square root of 35, which is going to be like 5.9-ish. Change it to a negative. And then multiply that by -6.
35.496.
Okay, minus 35, we're -35. 0.496.
Mm-hmm.
All right, coming over here. If we square, well, you know if you square a negative square root of 35, you're just going to get 35. And if we multiply the 6 times the negative square root of 35,
Negative 35.496.
add a 35 to that,
0.4.
negative 0.496, but then you have to take the absolute value, which makes it the positive 0.496, and that one checks out as well. How many have the negative 7 and the negative square root of 35 on this one? All right, questions at all? Any questions on the homework? All right, let's get to some normal-ish problems, though, because these were all so weird. We have worked slightly more normal equations, and I don't want you to have to miss them too badly. So here's some slightly more normal problems for you. Some of you have to deal with really weird problems at home, too. So twin brothers and such. Younger brothers who have, or older brothers who have birthdays and whatnot. Dads who have too many inflatables, you know, whatever.
That's not him.
You can tell I'm fairly confident he doesn't watch my YouTube videos. Kendall's like, yeah, he's gonna watch this one. It's a good rule in life, never insult a man with more shotguns than you've got. Or a man who's 6'9" and, you know, weighs 400 pounds. Abby's finished already. You did do both of them, right? I was just waiting for, oh, did we have to do both of them? Brandon's right behind her. Well, technically he's in front of her, but order of finish. I need more sleep at night. Pick up Genesis. Okay, at least when I call on you, I haven't been like, welcome to Chicken Salad Chick. Slightly embarrassing.
I wouldn't say that.
That's not what you say when people come up to the counter?
No.
No?
Say welcome in.
I just welcome in. It's a great day at Chicken
No.
Salad Chick.
No.
It's my pleasure to serve you.
Welcome in what you want.
How many of the factoring correct on this one? And so x squared was negative 9, x squared was 2, and so positive negative 3i when you take the square root, and then just the irrational positive negative square root to 2. How many have these answers? Excellent. On the next one, we had to set it equal to 0. What did it look like then, Audrey?
X cubed, negative 5x squared, negative 36x equals 0.
Good, that descending order. But we're not ready to backwards FOIL because we have to take out the common factor x. I got to work on my pointing skills. I was actually pointing at Audrey. But thank you, Maddie. You were ready to jump in there. Audrey now. What are we left with when we pull out the x? Thank you, Maddie.
X squared minus 5x minus 36.
There we go. If I put it over here and Maddie still answers, that's on Maddie, not me. But that may have been on me. And so we backwards FOIL.
And you get 9 and 4, x.
9 and 4x.
X and x.
Oh.
Yeah, negative positive.
Negative 9, positive 4. There we go. So what 3 answers do we end up with for x here, Michael?
0, 9, and negative 4.
And again, we're not checking these because there wasn't anything where we're raising something to a power which could create extraneous roots. So we're going to go there. How many had all 3 of those correctable? So, all right. Still working on it?
Yeah.
All right. On the right track? Any questions at all? All right. Next section, your notes. I introduced this yesterday, but I didn't give you any notes to write down, so we're going to take it as if you hadn't seen anything from yesterday. Polynomial equations not in quadratic form. Polynomial equations not in quadratic form. Polynomial equations not in quadratic form. First thing I want you to get down is that sometimes you can set equal to 0 and factor by grouping. Sometimes you can set equal to 0 and factor by grouping. And we looked at an example like that yesterday. We'll look at another one today. If we had an x cubed, positive 2x squared, negative 8 is equal to 4x. Okay, we can tell here, right, we've got the cube as my highest power, which we actually just saw a moment ago, right? Cube squared first, but there was a common x that could come out. And there were still just the 3 terms where once you pulled out the x, we had squared first gone. Well, here we're not going to have that. But we can still, in this example, set equal to 0 and factor. And this is what I'd always look for first, because to me, this is the quick way. This is the way we want it to work out. It's just, Murphy's Law generally doesn't work out. Kendall, let's take this.
X cubed, positive 2x squared, negative 4x, negative 8 equals 0.
There we go. And then from here, if we factor by grouping, remember, we're going to look at this set.
You have x squared, and that leaves x plus 2.
And then in this set,
Negative 4.
good, not just a 4, but a negative 4. Then be careful as you factor the negative 4 out of both of these.
X plus 2.
X positive 2, good. And that produces, remember, the common binomial factor.
X plus 2.
And in parentheses leaves us with
X squared, negative 4.
all right, and then from here, since we have both factors, we can set them both equal to 0. Here we're going to get that x equals,
Negative 2.
and here we're going to get that x squared is equal to 4. So therefore x is equal to positive and negative 2. Technically, this is a duplicate answer over here, so we don't necessarily have to include it, but there are 3 answers. 2 of them overlap, and then 1 distinct root there. We looked at one of these yesterday, and if all of them worked out this way, frankly, this isn't a really hard section at all. Questions on the factor by grouping method? Does that make sense? But then yesterday, and even despite Maddie's concerted efforts after the video ended, she was determined, and did I say Maddie?
Yes.
Abby. Did I do that earlier in the hour too? No, okay. All right. But despite Abby's concerted efforts, we realized that this wasn't going to factor. We even tried rearranging it, and it just doesn't factor. So method number 2, the second method that we could use, is to find a single root and divide it away. Find a single root and divide it away. And if you thought backwards FOIL was trial and error, this is trial and error. And to me, it's a lot more annoying than backwards FOIL, but it's all we've got. So with this method, I guess if we wanted to kind of subnote this, since we've already used number 2, after that would be little a, if we're in outline form, right? Part would be to list all possible rational roots. List all the possible rational roots. By the way, a lot of times math texts would use the term zeros. The idea behind the term 0 is it's a number that if you plug it in for x, it will equal that 0 that you have. Does that make sense? So they call them the zeros of the polynomial. Root, it's an answer, all possible rational roots. Well, somebody smarter than me decided that the formula here is going to be p over q, where p, for no apparent reason, is all factors of the constant. I can't spell. And q is all factors of the leading coefficient. So we're going to make a list of every possible rational answer. Now, This may only have, we know it has 3 roots. Do all of them have to be rational? No. It could have imaginary roots. It could have complex roots. It could have irrational roots. We can't account for those, okay? There's no way to account for that up front. But if there is a single rational root that we can find, we're going to list out what they are. So what we're going to do is we're going to make a fraction. We're going to list all the factors of the constant. Variable term, variable term, variable term. There is no variable here. We call this the constant. What are all the possible factors of a 12? Well, 1, 2, 3, 4, 6, and 12, right? Those are all the factors that could be in a 12. The big sigh of relief for us on this problem, at least, is all the factors of the leading coefficient. Well, when it's arranged in descending order, the first term is the leading term, and its numerical coefficient is the leading coefficient. I love it when it's a 1, because that means all my possible factors class are, yeah. Now, technically, there's positive, negative on all of these, right? You could have a positive or a negative one, a positive or a negative 2, a positive 3 or a negative 3, right? So all of these are possibly positive or negative. You could say, well, what about the 1? Is it positive or negative? Yeah, it is, but if you divide a positive by the positive, it's still the positive. You divide the negative by the positive, it's still negative. And if you divide by the negative, it's now negative. Divide negative by negative, it's positive. Don't worry about that. Just apply the positive, negative in your mind to the numerator. And literally, step B, test possible roots until one works. And for those of you who are not really good on your math skills, you're going to be thankful for your calculator. And some of you are going to be really thankful you did rapid calculations when you were in your younger years. So, I always start with the easiest number on the page. If you divide all of these by 1, you get this row still, right? The easiest of all the numbers here is a 1. So I'm going to try 1. And you're just going to plug 1 in for x and see if it works. If you cube a 1 class, you get what? 1 squared times 2. 1 times negative 11. And then, of course, we have this negative 12, all equal to 0. Is that a true statement? No. Okay, 1 doesn't work. Okay, then we go to the next easiest number. Now, some people, that's 2. To others, it's negative 1. It's up to you. It's whatever number you want to try next. I'm pretty good with negatives. I'm going to try the negative 1 next. Cube a negative 1 class. Negative 1. Square a negative 1, though. And times the positive 2 is positive 2. Negative 1 times negative 11. And, of course, we have this negative 12. Does that equal 0? Ah. So we found a possible rational root. We found a root that works. Now, we got it on the second try. Admittedly, there may be times you go through 3, 4, 5 of these before you find one. That's why I say there's a lot of trial and error, because you're trying to figure out just one root that works. Here's what I want you to realize. That means I know I'm going to get 3 answers, right? You paying attention? I'm going to get 3 answers. X is going to equal something, something, and something. And I know one of those answers already. It's negative 1. But here's what we need to understand. If x equals negative 1, then that means that x positive 1 is a factor. Does that make sense? For x to equal negative 1, we know it does. We just checked it, right? Then that means x plus 1 is a factor. Now, there's no way through any of our factoring techniques before that you would have figured that out. But the PQ method, if you want to call it that, whatever you want to call it, worked to tell us at least this factor. Or remember, factoring is division. What is factoring, class? Division. So if I want to find the other factor, I'll have to divide this one away. And that'll tell me what the other factor is. Does that make sense? That's part 3 under this, or little letter C. But we're dividing, class, by a variable plus or minus a number. So I ain't doing long division. I'm going to use, it's been a while, synthetic division. Good. So we're going to use synthetic division to find other factor. By the way, here when I said list all possible rational roots, all possible zeros, again, the point was to get a factor that works. We found one, x plus 1. But we're going to use synthetic division now. And remember, synthetic division involves a half box. And remember I told you that when you divide synthetic division, you don't actually divide by the number, watch, you divide by the inverse of the number. And I told you later I'll explain why we divide by the inverse. You're technically dividing the root away from the factor. Does that make sense? X plus 1's the factor, but negative 1's the root, and we divide the root away. Or you could just remember, change the sign of the number here. And remember, we're going to list all the numerical coefficients next to it. 1, positive 2, negative 11, negative 12. Been a little while since we did synthetic division. Is this coming back to you? Half box, list out the numerical coefficients, and I like to draw my equal sign, and I draw a little line to set off a remainder, but we guarantee no remainder. Unless you botched this, okay? If you actually did it right and you checked to make sure it works, you will never have a remainder because it divides evenly. I already know it divides evenly because I tested it. So remember, we'll bring down the first term, and then we do 2 steps to remember what they are. Multiply and add, multiply and add, multiply and add. So we multiply to get, and then we add to get. We multiply to get, we add to get, we multiply to get. And it better not come out with a remainder. If it does, you either botched the division or you botched your checking earlier. But it kind of, do you see how there's at least a built-in check to keep you from getting too far down the road on the wrong path? Now remember, this doesn't really mean 1 plus 1 minus 12. It means 1x squared, 1 power less, plus 1x, negative 12. That's the other factor. And here's the hope, is that this can factor further. And it can, because that's quadratic. So part D, I'm really running out of room here. Part D, need a second chalkboard for this, but it can't, you know what? I can turn the camera. We did it once before, I remember that. Now I'm going to turn the camera, we're going to do part D. It would help to be able to see where I'm turning the camera, wouldn't it? Hi, Gavin. Hi, Brecken. Not you, Brandon. Don't worry, I'm not getting you in the camera. Child privacy laws and whatnot to protect minors like him. I guess you could be on camera if you wanted to be, Genesis. You're an adult now, right? Just had your birthday. You're 18. Do you want to say hi? No, you don't. I didn't think so. All right, and then, so part D, letter D, is to factor the remaining polynomial. Factor the remaining polynomial or use the formula. If the quadratic you are left with, and I think I might have just gone off the camera, if the quadratic, oh, it's down here too, that we're left with is factorable, then factor it. If not, we'll use the quadratic formula. Good news is, I can factor this class. The x squared splits into signs, and the 12, positive 4, negative 3. So those are really my factors, right? It's really x plus 4x, negative 3. So that tells me now, what are my other 2 roots class?
Negative 4 and 3.
Negative 4 and positive 3. And there's my 3 answers. Now, I will say this, before you absolutely panic, okay, because you're like, that's so complicated. Well, it went really slow because I took a long time to explain it and talk and have you write in between. When you actually work the problems through, they don't really take you that long. Also, today, we're really just going to practice in steps. Tomorrow's where we're going to try to put it all together. But I do want to practice each of these steps individually now. So if you would, go and turn your books to page 127. Page 127. I want you to notice the first section on page 127 just wants us to make a list of all the possible rational roots, the P over Q thing. So look at number 6 with me if you would. Number 6, there on page 127. Remember the P is all the factors of the constant. What is the constant in number 6 class?
2,
2. All right, what are all the factors of 2?
1 and 2.
1 and 2. Technically, positive, negative 1 and positive, negative 2, right? The Q represents the leading coefficient. What is the leading coefficient in number 6? Negative 10. Don't really worry about the negative, though, because the negative could be up here as well. What are all the factors of 10?
1, 2,
2, 5, 2, 10.
All right, so then, if we divide these, do this with me, we're going to divide the 1 by all of these, then the 2 by all of these. So 1 divided by 1 is
1.
1, or positive negative 1 divided by 1 is positive negative 1. 1 divided by 2, or positive negative a half. 1 divided by 5.
Positive negative
1 divided by 10.
Positive negative 1.
Now 2 divided by 1.
positive negative 2,
2 divided by 2,
positive negative 1,
but that's already on here. We don't need to list it again. 2 divided by 5,
positive negative 2,
and 2 divided by 10.
positive negative 1/5.
Good, 2/10, but it's 1/5, which is already on the list. These are all my possible rational roots. Now, I will say this. If I'm testing them, I'm going with 1, and then either negative 1 or 2, and then negative 1 or negative 2, right? These are the ones I'm testing first. I don't want to touch the fractions. And I pray that one of these 4 works, right? But these are all the possible rational roots we would have. One of these surely has to work. You hope it's not one of the fractions. Let's do another one. Let's do number 8. Again, P represents all the factors of the
Constant,
constant. So we're starting with the constant, which is
negative 14,
negative 14. What are all the factors of a 14, class?
1, 2, 7, 14,
1, 2, 7, 14. Positive, negative on every one of them. What are all the factors of, well, what is Q, class?
2,
The leading coefficient, 2. What are all the factors of 2?
1 and 2.
1 and 2. All right, so then, Maddie, what are all my possible rational factors?
positive negative 1, positive negative 2, positive negative 7, positive negative 14, and then positive negative 1/2, positive negative 1,
Which is already here,
and then positive negative 7/2, and then positive negative 7.
which is already here. Do you see what she did? She took all of them and divided them by 1, and she took all of them and divided them by 2. But there were a couple duplicates. 2 tooths is the same as 1, and 14 tooths is the same as 7, so we didn't need to write them down. Here you've got a lot more options, but I still really hope it's one of those first 4, right? You hope one of those ends up working out for you, and the person writing the problem isn't, just an awful person. Or mad at you for some reason. I don't know why. Some people, I don't know, maybe get mad about red balloons. I don't know. Not me, of course, but maybe other math teachers. All right, number 10. Again, if we want to list all possible rational roots, class, we start with a fraction, P over Q, where P represents the factors of the
Constant.
constant. What is P, class? Constant. All the factors of the constant, which is what?
Negative 12.
And then, or negative 12, I think you said. And then the Q, class, is the
Coefficient.
leading coefficient. Don't get it backwards. Okay? Constant over coefficient. How do you remember that? I don't know. Memorize it. All right, and what is our coefficient? 8. All right, what are all the possible factors of 12?
1, 2, 3, 4, 6, 12.
And of course, all of those are a positive, negative. What are all the factors of 8?
1.
Positive 1, 2, 4, 8.
There, don't too lazy to write the positive, negative in the bottom because it won't end up mattering. All right, birthday boy, you with the red balloon, Bob the second. What are all my possible rational roots?
1, 2, 3, 4, 6, 12. Positive, negative problem.
Okay, hold on. Okay,
Then we got 3 tooths.
well, you skipped one.
1/2.
1 tooth, then
Yeah, 3 tooths. Then we got, that's 3. We already got 3. And we already got 6.
right.
And then we gotta go 1/4. Then we gotta go 3/4.
Because 2/4 is already a half.
1 1/2.
Well, that's 3/2. That's already up
Oh,
here.
yeah. Then we already have 3.
Good. All right. So we're done with that. Okay. Now we come to the 8. So
1/8. I'm thinking.
2/8 is up there. Okay. 3/8.
And we should be good.
And that's it. Now, to be fair, I will say this, class. I don't normally, to be honest with you, I don't normally list them all. Because I can do in my head the first few, and I'll run off of those. Do I really need a comprehensive list? Because since I already know I'm starting here at the beginning with these ones, probably not. But it gives us practice seeing these are your options. One of them better work, right, in order to do the process. Now drop down to the next section, where here they've given us a factor. The question is it really a factor? Or is it a lie? Is it fake news? Look at number 13. They've given us the polynomial. Let me erase and give myself some room here. They've given us the polynomial x to the 4th positive 6x cubed negative 5x squared negative 32x positive 40. And they've said, we've got this factor x negative 2. Is it actually a factor? Well, if x negative 2 is the factor, class, what would be the potential root? Positive 2. So let's see if positive 2 is really a root, if this is really a factor. And we just plug it in. 2 to the 4th.
16.
2 cubed times 6. 2 squared times negative 5.
Negative 20.
2 times negative 32.
Negative 64.
Plus 40. If this equals 0, that's a factor, and that's a root. If it doesn't equal 0, it's a big lie. So what's the verdict?
No.
No.
It's a lie, not a factor. Let's do number 14. Number 14. We've got x to the 4th, positive 3x cubed, negative 21x squared, negative 43x, positive 60, is or is not x plus 5 a factor? Well, what would be the root that would have to create a 0? Negative 5 would have to be the root or the 0. Ooh, calculators, negative 5 to the 4th? Actually, this is one we memorized. Yeah, positive 625. Negative 5 cubed,
125.
negative 125 times 3.
Negative 375.
All right, and again, if you need a little more time, obviously homework, quizzes, tests, you won't have to necessarily be keeping up with others in the class. Negative 5 when you square it, I can't do this in my head, times negative 21.
525.
Negative 525. You like that one? Okay. Negative 5 times negative 43.
Negative 215.
Well, negative times negative, I've got a
It's
positive 215. We do have to be careful with signs. Only plus 60, yes or no equals 0. Yes. So that means this is a factor. This is one of my roots. But that's what you'll do once you've made the list and you just start trying numbers, is you'll plug it in and see if it works. And if it does, I would do the synthetic division. I'd put the root in here, and I would divide synthetically to find out the rest of the polynomial. We go from there. That's all we've got time for today. So we're going to have to leave off there, I'm afraid. No homework for you this evening. Tomorrow, we'll kind of recap these steps again, and then we'll actually go through the entire process tomorrow as well. Again, very different from all the other problems we've worked, because everything else has been able to factor. These ones, not so much. That's what we're working on there. When the bell rings, you'll be dismissed. Have a wonderful rest of your day.